Hello there. In this problem, we're going to be using a different analysis using mesh current analysis. In this problem, this is the same problem as we did previously, but we're going to be using a different method to find I/O through this 2 ohm resistor and VO across this 4 ohm resistor. First, when using mesh current, uh, we have to find our ground node, and then we define each mesh current in a clockwise direction just to be consistent. So you want to count the number of meshes you have in your circuit. In this circuit, we have 3 meshes. As you can see, each mesh is its own loop. A mesh is a loop without any other loops inside. See this, if we go up here, 12, this is a mesh. 12 volts through the 6 ohms and then 2 ohms. This is a mesh. This is also a mesh where we go up from ground, 2 ohms through this 4 amp current source and then down this 4 ohms. We could also go the other way. This is also a mesh where we go from ground up to 4 ohms, 1 ohms, and then 4 ohms back around again. Now, this is not a loop where we go from ground and we go to 12 volts, 6 ohms, and then go 4 amps and then 4 ohms. That is not a mesh. That's not a mesh. That's a loop, but that's not a mesh. A mesh is a loop containing no other loops inside. So essentially, a mesh is its own loop. So let's define, use the number 2, define our mesh current in a clockwise direction. Mesh current 1, we'll call that I1. I2, and I3. After defining our mesh and its current inside the mesh. That's why it's called mesh current analysis. And now we apply Kirchhoff's voltage law for each mesh. So our equations will be adding up voltages. Essentially, when we're using mesh current, we'll be adding up voltages. With node voltage analysis, we were adding up currents. Okay, then let's do this. All right, so mesh one. All right, from our ground node, we go up 12 volts. So 12 volts is on one side, which is a rise, and this is a drop. This is a drop because currents always go from plus to minus. So that equals to 6 ohms times I1. Why? 6 ohm, because using Ohm's law, V is equal to IR. We're multiplying this mesh current by this resistor. And now we just went up 12 volts, down 6 ohms, and then now we'll go down to 2 ohms. So that's plus 2 ohms times this current that's going down here. This current is a combination of I1 minus I2, right? Because the I1 is going down 2 ohm resistor, and also this mesh current is going down. So it's I1 minus I2 and we go back down to ground. And we go back into the same loop. So now we write an equation for mesh 2. Mesh 2, well, first of all, we have a 4 amp current source. We tell that if we have a current source and it's not touching any other mesh but its own, then we can say that this mesh current I2 is the same as this current source. So I2 is 4 amps by inspection. Now let's move on to our last mesh, I3. Now we'll go up since we have no current source, and that we can't do the same method that we did for mesh 2. Let's write our equation. Starting from ground, we're going through this 4 ohm resistor from plus to minus. Don't be deceived by this voltage part where it's plus to minus. This is another convention, but current always goes from plus to minus through a resistor. So we have 4 ohms times I3 minus, notice that I3, the current through this 4 ohm resistor is going up in this direction, which is the same direction as I3, minus this direction of I2. So that's I2 plus 1 ohms plus 1 ohms times I. Let's erase that. That's bad. 1 ohms times I3, which is essentially I3, plus 4 ohms times I3 is equal to 0. Now, first of all, we know that mesh 2 is 4 amps, which is equal to I2. See this mesh 2 has a mesh current of 2 amps. Oh, 4 amps, my bad, sorry. And we can substitute 4 amps into I2, 4 amps into I2, and solve this system of equation. Now let's plug it into our first equation. 12 is equal to 6 I1 plus 2 I1 minus 4. And make sure I wrote that right. Okay. Now that simplifies into 12 equal to 6 I1 plus 2 I1 minus 2 times -4 minus 8. We'll add 8 both sides, so we have 20 equals to 6 plus 2 is 8 I1, and 20 divided by 8 is equal to I1. Put that into our calculator. 2.5 amps. 2.5 amps. So now that we found I1, let's solve for I3, or the mesh current for mesh 3. We can distribute, we'll substitute 4 amps into I2. So we have 4 I3 minus 4 plus, we'll add that, that's 5 I3 equals 0. Okay. Let's clean this up a bit. 4 I1, excuse me, that's supposed to be 3. Minus 16 plus 5 I3 is equal to 0. 5 plus 4 is 9. 9 I3 equal to, add 16 on both sides, 16. So I3 is equal to 16 over 9. Divide both sides, top and bottom by 3. We have, well, we can do. Let's see. So 16 over 9 into our calculator. 1.7788 amps. 1.78 amps. Okay. So we now found what I1 is, I2 is, and I3. All right there. Okay, so we found our mesh currents, and then we need to find I/O. I/O, what is I/O? Well, I/O is going down through this 2 ohm resistor, which is a combination of I1 and I2. But which one goes first? Which one do we subtract first? Well, we take our mesh current, the one that's in the same direction as I/O, and subtract it from the other mesh current. So we have that I/O is equal to I1 mesh current, I1 minus I2. I2. And what does that equal to? What do we have as mesh 1? 2.5 amps. 2.5 minus I2, which is 4 amps. 4. And we have 2.5 minus 4, negative 1.5 amps. Okay, negative 1.5 amps. So I/O is negative 1.5 amps going through this 2 ohm resistor. And we need to find VO, which is VO here. Well, we can find the, well, we can find the current through this resistor multiplied by its uh, resistance, and then find VO. Well, here, this is how we can use, let's see. So from going down, plus to minus, VO, see VO is defined as plus here and minus here. So we have to subtract I2 minus I3, which is the current going through 4 ohms, I3. Okay, what is I2? 4 minus I3, 1.78. 4 minus 1.78. And we have 2.2 amps. And we can we multiply that by 4 ohms to find VO. So VO is equal to 2.22 times 4. We have 8.88. Make sure that's right. 2.22 times 4. 8.88 volts. And that concludes our video for mesh current analysis in simple resistive circuits. Thank you for watching.